right. I've been wanting to meet you for a while. You've been on my radar. We've been connected on LinkedIn, liking each other's
Yeah,
posts.
definitely. Yeah, same here. I mean, like I've been watching everything, following you since the start. I mean, just going through all these providers for 3D printing, and it's been nice. It's been nice, an archive of history of what's going on and how things are moving forward. So, kudos to you for a great job.
Thank you. And thanks for coming on today. So the main reason I wanted to have you on the podcast was because of your work trying to create a construction code, an international construction code with the group
Hmm.
JG80 to implement 3D printing in construction and have a system where people understand how it's supposed to be done on a job site, and maybe setting a framework for people to continue exploring with these new technologies. So can you explain a little bit about that?
Yeah, sure. And just a little bit of background. I mean, I've been working in the construction sector for about 15 years, GCs, and Middle East, and North Africa. And we embarked on a 3D printing project back in 2018 in Saudi Arabia with the Ministry of Housing. And we had subcontracted the 3D printing initiative to a contractor, a technology provider, Saudi at the time. And basically, we were responsible for the engineering. We were responsible for all the general GC responsibilities and such. But also, as soon as we got the design for the house that was supposed to be printed, there were some issues that came out. And basically, the structural elements and how we're going to certify the structure and where are the columns and where are the beams and are the walls load bearing and so on. And we as soon as the design came into play, we had to retrofit the design so that it looks more conventional. So we had to put in the columns, we had to put in the beams just for reinforcement so that the roof can stand, even though the elements in the walls could actually hold maybe 4 or 5 times the weight of a conventional structure.
Mm-hmm.
But still, because of lack of standards and lack of ways to actually do a one-to-one comparison, it was difficult. So we just had to opt it, even though it was unnecessary, we still had to opt for the rebars and the columns and so on. So, and that happened with the first iteration of the building. There were supposed to be other projects with the Ministry of Housing in Saudi Arabia, but that didn't come through due to financial reasons. But then as we started tendering for different projects in Dubai, mainly with the transportation authorities and for the water and electrical authorities in Dubai. Again, the standards and the issue of standards that you're following and the certification of these structures came into play.
Mm-hmm.
I have since moved, left the company and moved to Toronto area beginning of last year. And this issue of standards kept on bugging me because you're seeing all this advancement in technology and 3D printing and construction. There's a lot of interest now growing, but it's like everybody's rushing to just hit a wall, and you just stop at some point because either you're doing one-offs, but you cannot go scale and you cannot go commercial because of the lack of standards. So I asked around. I started off beginning of last year asking around if anybody had an initiative going on. Nobody had anything solid in terms of putting an infrastructure together. So I said, okay, well, let's start it. I mean, I reached out to Tufsud at the time, and they told me, look, they've been thinking about doing something like this, but they need support from the market. And I said, okay, just leave that to me. And I got in touch with everybody I knew at the time. And there was a lot of interest. I mean, many people are facing the same issues. I mean, people are printing bridges, houses, formwork, infrastructure, and structural elements, and they're always running into this issue of standards and certifying the structures. And it was an optimum time to actually get everybody together and say, look, at some point, you guys are going to compete with each other in this market, but at least you have to come together in order to define the standards. And we were able to do that. So we got the attention of ISO ASTM as of the beginning of this year. So March 25th, we had our first meeting, and that's how Joint Group 80 was created. Hopefully, we're going to fast track this process so that it doesn't take 5 years to get this thing done. But hopefully, we're optimistic enough that we can think that we can have something by the summer of next year.
And so they're eager and ready to work with you and implement some of these standards?
Yeah, and basically what we're looking at is we're looking at the structure or the quality of the end structure or the end product. We're not necessarily looking at specifically getting into material specifics or solution specific. And of course, in the 3D printing market, there are many solutions. You have gantries, robotic arms, telescopic arms, and so on. And everybody's using different materials as well. So we're trying to encompass as much or as many providers as possible for the existing market and for the market that's to come. So, and you have the GCs who are also very interested, especially here in North America. It hasn't been so fast paced as of the past, but as of this last year, the past few months, I mean, there's been a great interest in 3D printing in North America.
Yeah, there have been quite a few catalysts this year between COVID, lumber prices, all these different things intertwined. People are becoming more and more interested in alternative construction solutions.
Yeah, and basically when COVID came into play and you have social distancing, you have a shrinking labor market, the consciousness of material sustainability, eco-friendliness, and all that kind of, that also plays, 3D printing plays a good part of that. And the way I try to explain it to GCs is that 3D printing is not supposed to replace your workforce, it's supposed to help the workforce. It's safer, you get more productive, you're saving on material, you're being safe on the environment, and now, especially now with COVID and the social distancing type thing, you can have the 3D printer help your labor force actually print structures and instead of doing formwork and traditional means of going through the process.
Mm-hmm. I spoke with your colleague Sophia for a while on the phone, and I got the same idea or general concept of your group that I'm getting from you now, is that your goal is to speed up the use of this technology rather than create regulations that will prevent it. So right now there's no framework. So when people go to do projects like this, especially in the traditional construction world, nobody has any idea what's going on. They don't understand how to treat it. And so by defining it clearly, you give people a better chance of being able to integrate it into traditional projects or convince traditional thinking people who are used to the way things are used to be done that this new technology has a place in the new construction world.
Exactly. And the biggest thing is for people to actually experience it. I mean, you have to feel it, you have to touch it, you have to see it, you have to see the reality of it. It's not some science fiction type solution. It's a real solution that's there. And sometimes people are, or some GCs are very hesitant or in actually applying this technology because it's completely alien to them. They cannot relate to it. So trying to put the standards behind it, so to speak, is also having like ISO and ASTM, which are world-renowned authorities and standards. And when you go to a GC and you have ISO and ASTM behind you, and this is an ISO ASTM entity or document that's coming out and as a standard, then that takes, you're 70% of the battle is already gone. I mean, you just have to associate the standards that you're developing with the end product that you have or are presenting, but also in the sense that we're not reinventing the wheel in that sense. I mean, there are standards, ASTM and ISO standards and building codes that you have to abide by, and those will be listed in the standard that we're developing. So it's not completely alien. We're just trying to sort of make it an easy read so you can navigate your way through actually certifying 3D printed structures.
Mm-hmm. So how will a contractor using a printer interact with the regulations that are going to be set forward by JG 80? What will their relationship be there?
Yeah, and basically what JG80 or the standard that we're developing is sort of like defining the standard or defining the means of how you are setting up your shop, how you're doing your printing, how you're managing your material, your pre-processing, post-processing, your design, not necessarily the architectural certification of the 3D model, but let's say after the architect has certified your 3D model, then you get the BIM model or 3D model, and then we translate it into robotic code in order to do the print. So all the architecture aspects of certifying is outside the scope, but we deal from the printing process. So you get the 3D model, you set up your material, how are you storing up your material, the type of staff that you're going to have running the process. Also, we're dealing, for example, your like I said, processing, production, and then post-processing. What it takes, for example, if you're doing printing concrete, what are the specific ASTM or ANSI or ISO standards that apply to concrete structures if they're load bearing, certain tests that you have to go through. If you're using other materials, then other specifications will be listed. So in that sense, it's kind of like a checklist of what you need to go through. But also we're trying to handle on-site printing and off-site printing. So let's say if you have a BAM facility where they do their printing in-house in their 3D printing factory in the Netherlands, and then they ship the elements to the construction site, or other mobile solutions like TAM, for example, has their mobile solutions where you actually go on-site and start doing the printing. Those same standards apply to both scenarios and situations. So in that sense, it's sort of like our standard is sort of like a nucleus of a spider web. And then depending on the material and approach that you go through, you could just follow it up to the specific one. So the first section of the document of the standards is an easy read. It's probably no more than 30 pages. The appendices and the bibliographies and so on will be like 300 plus pages because it's going to list all the standards that would apply to specific solutions and specific materials.
Yeah, there's definitely a lot of variance in even just the material flow, whether it's going into a mixer pump or it's going into a bigger hopper before going into the pump, different types of pumps people are using.
Yeah, and then some people are doing layer on top of layer. Some people are doing shotcrete. Some people are doing different solutions as well. So, I mean, like we have to look at the different, some people are not even using wet material, like fast brick robotics as part of this committee as well, and they just lay bricks. So I mean, like we have to accommodate the different solutions and entities that are out there.
Yeah, that was one of my questions. Is fast brick robotics included in this regulation system?
Yeah, if I may, I'll be able to share my screen and show you if that's possible. Okay, you can see my screen?
Yes.
Okay, perfect. So, I mean, just from a high level point of view, Joint Group 80, this is basically what it is. We're looking at the quality of end product, like I said before. We're looking at the quality of structural and infrastructure elements, and we're looking irrespective of the material and the approach that you're using. So this is supposed to cover existing market solutions and more market solutions that are supposed to be coming. And when you look at the people that are involved, you have anybody and everybody, different solutions out there. Fast Brick Robotics is in there, 3D Vinci, V6, Concreative, Hyperion Robotics out of Finland, Icon, Changemaker 3D in the UK. So the list is huge. And if you look at the list and you know the background of these, you know that there's a lot of solutions out there, each using a different approach, each using a different material, each focusing on a different segment in their market. And for example, like Mighty Buildings, they are using compound materials. So they're not even using, for example, cementitious-based materials for that. Mm-hmm. So we're trying to incorporate as much as possible. So, and what's interesting enough, okay, Cobalt International is growing. And like I said, like in the US, they're actually picking up. So you have Printed Farms, as you know. Perry USA is probably doing something now with a Cobalt printer in Houston, Texas, as far as a recent read. So that's picking up as well. And it's picking up globally as well. So Cobalt has far reaches in India, Malaysia, Malawi, and different areas that are doing structures. So, and in the back of these technology providers, so to speak, you have the GCs. So B6 3D is based out of a major GC. Concreative is Frisinet. So, and then you have DPR from our side, and then BAM International is also a large contractor based out of the Netherlands. So you have the interest coming in. So they're like passive, behind the scenes type view parties that are interested in this initiative to see how things are moving forward. So once the standards come on, then everybody tries to use these solutions moving forward as a tool, like I said, in the construction sector to actually optimize performance for their projects.
Have you talked to Vasta in India? They just announced their house or inaugurated it or something.
Yeah, I've been in touch with so many different groups and properties in the sector. So, and also them, like if they're based out of Cobalt solutions, so then it's Cobalt is covering that sort of the umbrella of the different solutions that are out there. So, like I said, Camp C, Perry, 3D Vinci, Printed Farms, and so on. All of it are using cobot printers and cobot solutions. So cobot is like the umbrella that covers everything, so to speak, in that sense.
Is there any relationship between Mighty Buildings UL certified material and the JG80 group?
We're trying to, well, the thing is that, for example, like Mighty Buildings did the UL, sort of is working on something with the UL. Also AC 509, in that sense, also Black Buffalo is trying to actually upgrade the AC 509 standards so that they apply to two-story buildings. So that's something that they're working on. And what we're trying to do with that to be like a one-stop shop for the certification process without having to go to different branches in that sense.
I know you're trying to create a system that's like open-minded and makes it simple for people to innovate and come up with new solutions. Do you think that the regulations will be malleable enough to be permanent, or will they need consistent oversight?
Nothing is permanent when it comes to standards, especially with material being developed, new solutions being developed. For example, the company in Siberia is actually developing a 3D printer called Goliath, and they're trying to print 3D 2 or 3 story buildings. So the technology is changing all the time, the materials are changing all the time, the approach is changing all the time. So nothing's going to be solid that once the standard comes into play, then that's fixed. It's going to be something that's going to have different iterations moving forward. So I expect that this standard will develop with time. But if we have a version that's out there and the GCs can actually apply and use, then that's something that we can actually move forward with. And it will be a major step in actually accepting the technology as a different tool in the construction site to actually do the printing.
So JG80 will need continuous oversight as the years progress.
Absolutely. And as we get into the ISO ASTM, then the standard will also be exposed to the different work groups within ISO and ASTM. So you have the construction group that's going to have some say into this. You have the materials group that's going to have some say into this. And also the additive manufacturing group will have say into this. QA/QC, safety. So all these different groups within the ISO ASTM certification bodies will have a say into the standards. So anything that comes into play with that will actually lead to a change in different standards.
What's the time frame you see these standards being implemented?
Like I say, I mean, like we're trying to do optimistic 1 year type turnover to actually have the standards issued and published and translated into the several languages that they get translated to. That's the goal. So I'm trying to push for that and stick with that. Normally, standards usually take anywhere from 3 to 5 years when you're talking about ISO and ASTM. Mm-hmm. But we're trying to fast track it to move forward. So to as much as we can on our side, we already have a draft. We have our second ISO meeting coming up this Thursday, May 6th. And that will be where the draft actually goes out for voting and commentary to the various entities within ISO and ASTM for initial comments and feedback. So once we get that, we will try to do a turnover for the comments that were raised, and then actually maybe go for a second round of voting. So as soon as we go through the traditional processes, there's a certain way that things flow within ISO and ASTM, certain timeframes, so we have to abide by those. But as much as we can do on our side to speed things up, we're trying to do that.
I always imagined with such a significant innovation, there would be people trying to stand in the way that didn't want change.
It's not, well, construction in itself is not exactly an easy sector to actually change. The company I used to work for is a 70-year-old traditional privately owned company, CCC. It was based out of Athens with major, like I said, major projects in the UAE and the Middle East and North Africa and all globally as well. But again, getting to them to actually 3D print a house was it took time. And basically you have to know how to approach the company, how to explain the technology, and not that in an abrasive way that here, okay, you guys are doing things the old way and here's the new stuff. So it takes a lot of buy-in. It takes a lot of doing a one-to-one comparison. And once you do that, then and they see the benefits of it. And again, like I say, you feel it and you touch it and you see it and you realize the benefits of it. and then it becomes just like anything else, another tool in the construction site.
Mm-hmm.
So, but I also like from ISO ASTM standards, they have their own rules and own ways of doing their things. But again, we have to abide by that and accommodate those ways of doing business, so to speak, and the traditional means of moving forward. And we try to find some kind of working relationship that we can actually make this happen. So everybody's happy in the end, so to speak.
How are those regulations ultimately enforced?
Usually the way we do it in construction, when you are ISO certified, you get audited by ISO on a recurring basis. So you have to make sure that you're abiding, you take the standard, and then you have to make sure that you're actually following these standards or these regulations that are issued by ISO. In order to maintain the ISO certification, you have to pass the audit that goes on on a periodic time frame. If you don't pass the audit, then you're given a time where you can actually amend. But if you don't amend, then you lose the ISO seal and certification. So that ISO seal and certification that you see on company websites and documentation is actually earned and kept. So you get audited on a regular basis. It's not that you just get the standard and you move forward, and that's it. You have to maintain the quality that the standard actually issues, and that's how ISO actually maintains its credibility. The same thing with ASTM as well.
Mm-hmm. And is that necessary for doing business? If somebody loses their ISO certification?
Absolutely. Especially on the general contractor side, if you have ISO certification, again, when you have a strong body like ISO ASTM behind you, and you come as a subcontractor or a technology provider to a general contractor, that pushes away a lot of the initial questions and hesitation that you might have, because you're already certified by ISO and ASTM. So that makes it easier for you to actually get in the door. And then it's just checking off the boxes as to specific questions that the general contractor or the client will have at the time. So sometimes in your tender documents, being ISO certified and so on is a prerequisite for actually anybody getting into the door. So you have to provide that kind of certification.
What about smaller prints, like a smaller machine that is doing concrete objects for furniture or something like that? Do the regulations apply there?
No, not necessarily. Only because, like, when you have urban furniture and, let's say, security bollards, for example, or some kind of non-structural or non-critical type elements, you don't need the certification for that. Again, most of the material is like 4 or 5 times stronger than the conventional concrete. So, and the nice thing about 3D printing is that you get, like with parametric design and generative design, you can get different design variations. So instead of having a square or rectangular type shape, you can actually have something very nice within a few minutes. So the standards not necessarily apply to the non-structural or non-critical elements, but for critical elements and structural, that's where things are moving forward. Especially now, for example, Saint-Gobain in the Netherlands actually printed a house and got published in the last few days. So things like that, where the housing is coming into play, and according to United Nations study by 2050, I think it was, that the world population is supposed to grow to almost 10 billion. And in order to accommodate the housing for this population growth, people are expecting that or predicting that a city the size of Paris needs to be built every week for the next 40 years.
Wow.
So when you talk about that magnitude and that kind of those kind of numbers, that's where 3D printing really comes into play and can help people actually address that need that's anticipated to come.
Yeah, I've heard many rumors about material improvements that are on the horizon. Mm-hmm. Specifically, they say something can be added to a regular concrete mix that's less than 0.1 the weight percentage of the concrete and make any typical concrete mix printable. Have you heard of something like this?
Yeah, and I mean, you have material suppliers that are actually looking and doing their research on this. Lafarge Holcim is one, Laticrete is another, Sika is doing studies, and then you have these individual smaller technology groups that are actually focusing on that. So the materials is constantly changing, and everybody's using a different speed and extrusion speed and different way of mixing their materials. So it goes without saying that the material, and some people are using actually fiber in order to reinforce the printing instead of putting an embedded steel concrete like BAM or Saint-Gobain is using with their structures. Mm-hmm. So there are different type of mixes coming out there. But again, when you put in fiber, the material becomes very thick. So then you have to have concerns about the pump and the printing head. And also using self-healing concrete, for example, if it cracks, that it fixes itself. So again, it's things that are moving forward. More eco-friendly type cement, if that's a proper phrase. But the material is always changing. The technology is always changing. And recently there was something I shared on LinkedIn where a gentleman just used sand and sunlight to print. So just taking the sunbeam and focusing it on sand, and you get a glass structure. So there's no limit as to the solutions that you can provide in order to get something like this.
Yeah, that was a 2017 project, right?
Yeah, 2011, I think it was.
Oh, wow.
Yeah.
It's a long time ago.
Long time ago, yes.
Too bad there's no 3D printed sand glass buildings over there yet.
No, I mean, it's something that he did on a research project, and he went out to the middle of the desert, and I think it was Egypt or Morocco, and just a very simple solution, focusing light on sand, and the heat melted the sand, and he got a semi-glass structure. So zero carbon footprint, a very accessible solution, and it could be applied to construction as well.
So the material solution that could just be a little bit added to a regular concrete mix, what material do you think that is? Graphene?
That all depends on the solution. It depends on the climate, it depends on the solution, it depends on the availability of the material, but also what we're trying to focus on. I mean, it makes no sense to actually print a structure if you have to import the material. So wherever you're doing the print, wherever it makes sense, based on your local material, that's what you are supposed to be printing. It's one thing when you have to import the machine, and that's a given. Sometimes it's not available in the continent or the country that you're printing, but it is a definite requirement that you're using local materials. So whatever solutions, additives, adhesives that are being used to actually print have to be sourced and made available locally.
It seems to be like without some kind of material innovation or improvement, it'll be tricky to implement this technology on a wide scale because of the material cost.
Yeah, but again, when you're talking about material costs and you're talking about the printing, if you're doing printing for one solution, let's say I'm printing one house, mm-hmm. it's definitely not cost effective whether you're talking about one robotic arm or the material. If you're printing on a scale of, let's say, 100 plus houses, or you're printing on 200 houses, then you can offset the cost of the material and the solution spread across the 200 houses that you're printing, so that the price is not just sitting on one or two, three houses. And that's where things come into play. Like I said, but again, what's stopping people from actually doing these 100 prints and printing them, not printing, for example, mass scale in the US for 100 plus houses, are the standards and the regulations. So once that comes into play, then people can just go commercial, and then the cost will come down when it comes to printing, and that enables speed up for research and material, looking for alternative means, exploring different solutions out there. So things like that. I mean, the standards would just be like the stepping stone or the foundation for moving forward, and then everybody could just go have a field day with research and implementations and different solutions.
Yeah, I agree. I think the standards make it more investable. When people see that there's some kind of regulation, they're less afraid that regulation could ruin it when they understand the regulation.
Definitely. And then when you have a competitive market, just by existing competitive market, that's where people start competing in terms of price. So different providers will start competing on the price range, and then the price will start going down just to be competitive in the market as well. And this is just typical marketing and economics and business model. So when you have one or two that are actually providing it, then it becomes very difficult and very pricey. But when you have almost 100 or plus people providing that solution, that's where the price goes down, and then it adds the competitiveness of the material, adds to the competitiveness of the solution, and also the end product that you're actually delivering, be it on Earth or space-wise, and so on. So it's just a boost for everything to move forward.
That's kind of why I was asking about the material that they would add, like whether it's graphene or not. If it's graphene, that's kind of cost prohibitive for the time being. Maybe producing graphene will get cheaper, but the batch size that they need, there's so many different use cases for graphene that it's not going to be improved just because there's bigger 3D printed concrete batch sizes. There's a million other reasons they want to make it cheaper. Other materials could be different, but I guess what I'm trying to figure out is, will those economies of scale be immediately evident? Can you just buy 100 times as much of the special material and the cost goes down? Or is it a material that's in rare supply where it doesn't matter how many you order, it's the same price? Like gold is the same price for an ounce or 1,000 ounces.
Yeah, the thing with material, it's a very tricky thing. So I mean, like if you're using something that you can actually, that's readily available in the market without having to go on special type materials, then that's an easy sell. If you have to like bring in a special like tailored or specially genetically sort of like developed material that has to be put in place, that's where people get hesitant, because then, okay, what is this new material coming into place? So it depends on the situation. Like I said, geography, availability, the type of material, but also the buy-in that you kind of get. You don't want to go too far out there in terms of material, but you want to make it like something that people can actually be familiar with and moving forward, because the more conventional type materials that you're using, the more conventional approaches you're using, the easier it is for buy-in, at least from the initial stages, once people get used to it. And then you can actually go with that. So it all depends. But again, it could be that, okay, people accept unconventional materials and then move forward, or it could be that they would rather stick with normal, like most of the prints now are cement-based materials. So that's what they're comfortable with. And then once we can pass stage one, then we can go to the other materials.
Mm-hmm. Another, people use fly ash.
Yep.
Kind of limited supply material.
And fly ash has been around for 50 plus years. It's not something new that's been used. So, I mean, like fly ash in concrete has been used for decades, and people can relate to that. So in that sense. But new things, for example, bendable concrete, is still under study. There's, I think, one company in Japan that's actually printing using bendable concrete so that you can actually bend the structures, and that's just for seismic related incidents, but also using fibers, again, as part of the reinforcement instead of putting rebar and steel. So there's various materials that are being addressed and studied and looked at. So.
Yeah, my understanding with the fibers is, unless they're in tension when the concrete is curing, then they're not preventing cracks. They're just helping hold it together after a crack.
Yep, exactly. Yeah, but again, when you're putting fiber, you have to be careful, because then your pumping pressure has to be harder because the material is thicker coming out. So, and those things have to be considered as well.
If there were no improvements in material ever again of printed concrete, would the industry survive?
I think yes, it will survive, only because of the cost effectiveness that you would see, the productivity, the less material that you will use. I mean, with 3D printing, instead of printing with 4 tons of material, you can actually print with 2 tons of material, and it's more effective, less waste. So just the eco and the pricing, eco-friendliness, the carbon footprint, the productivity, the speed, those speak for themselves, even if you're using just the conventional materials. When people start developing more solutions and moving forward with their systems, the material just advances as part of the process. So
yeah,
technology and printing moves forward. Yeah.
So you're from the traditional construction world. How long ago and how was it that you first got introduced to printed concrete?
We started off, well, the company we were looking at innovative technologies for in construction. So we were, like I said, a 70-plus-year-old company that was doing things traditionally, and we started looking at innovative technologies. And we were looking at drones, we were looking at IoT, we were looking at using sound waves to actually predict maintenance on hardware and machinery. We had a huge fleet of construction equipment that needed to be maintained. So we were looking at different solutions to actually do business better and do things more effectively. And 3D printing was one of those. So we started off around early on, but it started picking up momentum around 2010 into looking at technologies, and finally made a decision and were able to actually pitch for an actual project in 2018 for the Ministry of Housing. So we were looking at, but also you have to, at the time before that, anywhere before 2010 and years after that, you just had to make sure there was a lot of buzz out of 3D printing. So you just had to make sure that you have to double check the facts. You ask the right questions. Are you really providing what the news brief says? Is this real or is it just hype? So we had to sort of like do the homework, and I was in charge of that, to actually address and fact check everything in that sense. Also talking to the different technology providers, see who is a better fit for this particular solution that we're looking at. So in that sense, it was sort of like fact checking in a sense, but also finding the right provider for the right solution to get the print product. And as we were doing this the first time, we only had sort of like one chance, because if you don't make an impression the first time over, then you lost their attention, and it's going to be harder to convince management and people who are actually giving you an ear to listen, that okay, if you screw it up the first time, you're not going to get a good chance to try to do it again. So we had one chance to do it, and we were able to do it, and we were successful in that. So a lot of pressure was on that initial step moving forward.
What printing company did you decide to work with in 2010?
Well, 2018, actually, when we printed the house, it was Sybay.
Yes, yeah.
Yeah. So we had, I think it was 24 elements for the walls that we actually printed. And it was relatively, we did that relatively quick. It was almost in a week's time, less than a week, that we were actually able to print all that.
Were there any companies that you reached out to back in 2010?
Yeah, I mean, there were many. Icon, when it first started, Apiscore, Contracting with Dr. Krishnevitz, so there were many companies that we were going out for. And Apiscore at the time had just printed their house in Europe, in Russia, so to speak. So that was a lot of hype around that. And then people were claiming that they were printing 2-story houses and were printing concrete horizontal structures, and you just had to filter through all that in order to get to, okay, who are the real players in this market? And Cobot was starting off in the time, and then established relationships with 3D Vinci, and 3D Vinci printed the house in Amar. So we were all like, for example, when I say we were looking for a specific provider for a specific solution, when we were bidding for in Dubai for several projects, we were bidding with us as a JC, for example, for the Ministry of Transport in Dubai. We were bidding with BAM Infra for concrete, MX3D for the metal, and the local company Immensa for the plastics. So it was like and then for another project for DIWA, which is Water Authority, we were bidding with Sybay. So it depends on which project and which specific solution you had, and we picked. And the way our approach for that is that we didn't have an R&D solution per se, so we didn't buy the technology, we didn't buy the material, and our approach was, okay, people out there already doing the solution, already have the material and the know-how and the skill set, so we subcontract out that work. And we hired the technology providers as a subcontractor, and that's a relationship that I think actually works, and is an opening door for other general contractors not to think that they have to invest so much money into buying a 3D printing solution, but you can actually create a relationship and always be on top of the skill set that's out there by just doing a subcontracting work and creating collaborative relationship with different technology providers.
Yeah, there's a lot of people that want to hire 3D printing subcontractors right now, but there's so few printers around and they're only in certain areas. So they might be in Tennessee or Oklahoma, but there's no printers in Tennessee or Oklahoma yet. So it's hard for them to find a subcontractor, whereas I guess you've established these relationships, so you're able to contact them and get quotes for jobs like that. Most people can't.
Yeah, and this is where I come into play. I mean, like I provide consulting and advisory in 3D printing, and many people, different institutions, different authorities, and different general contractors want to get into 3D printing but don't know how to approach it. And that's where I come in, and I can help address that with everybody to show them the best solution, to understand their needs. 3D printing is not supposed to come in just for a showcase and just be a flashy thing in the construction site. It's supposed to actually resolve a real-time problem or issue or need or pain that a general contractor is facing. So we try to identify that need, and I try to or help them actually use the right solution that actually addresses that need in the best way possible.
And I'm sure sometimes you have to tell them it might not be the best solution for the job.
Yeah, I mean, like when you just it doesn't make any sense to actually get $1 million printer just to print benches. I mean, it just doesn't make any sense. So, I mean, like if you're just printing for the sake of printing and you have money to throw away, which I don't think anybody has at this point, then yes, you can have a fancy robot that actually does that. But again, if you're just printing urban furniture or small items for indoor decorations and stuff like that, you can actually subcontract that out and have it shipped to the location as opposed to buying a printer and actually doing that.
I'm eager for the day where the printers are in abundance and people can easily rent time on one to print or just get quick projects done.
Yeah. And things like that. I mean, like anything's possible when it comes to 3D printing. Again, once the market starts hitting, then you have different variations of things. I mean, like we went from steam engines to combustible engines to now electric cars. So it's going to speed up, and things change very quickly. I mean, if you look at the phone, the mobile phone, we started with Nokia, and now we're in iPhones, and the difference is only like in less than 10 years or 10 years plus. So I think when 3D printing, and there's a lot going on in the background, but once you have an opportunity where people can actually do things commercially and in real-time solutions, that's where the advancement and evolution actually speeds up, because people are testing it in real life. They can go back to drawing boards if you need to fix anything, or they can find better ways to actually do that. But in order to actually be exposed to the commercial and the magnitude of 3D printing in construction, that opens up the doors to research, to possibilities, fixes, optimizing products and optimizing solutions, and thinking of new ways of doing it.
So is this project now consuming 100% of your time?
Mostly, yeah, but I'm still open to other opportunities. So I'm still talking to other people in terms of helping them, like I said, in the advisory to help them out. But yes, it's there's nothing sexy about the standards, but it's something that needs to be done. And so somebody's got to do it, so to speak.
Absolutely.
So it's not a printed robot that you can actually touch and feel, or a nice design that comes out of it. It's just a document that comes out of it. But again, the document is the foundation for everything else moving forward. So
you seem like the right guy for the job. My only fear would be that one day you're not responsible for JG80 anymore, and somebody else who has different intentions wants to use the regulations for different purposes.
Yeah, well, I'm not doing this for any commercial or benefit. I mean, like, this is on my own time. There's nobody's paying me to do this, and nobody's actually, I started this on my own, just by calling people up on my own time. I wasn't expecting the kind of response. I actually didn't know what to expect, because I'm calling people up and then talking about standards, and I was expecting everybody to just brush me off, and it's like, okay, yeah, well, whatever.
They know it's needed.
They know it's needed. It's an important thing. Everybody jumped on, and it's encouraging to see everybody involved, and people continue to get involved. And there's a lot of interest from different organizations. But again, I'm sticking with this, but it's not something I will let fail. So we're going to get this done.
Seems great. I think we've covered a lot of stuff. Oh, one more thing. I should have brought this up earlier. Do the regulations have anything to say about cold joint concrete, or like print stopping and resuming a print?
Yes, that's all part of the production process. So when you stop and start a cold print again, like what do you need to do, like an adhesive layer or anything like that, the special processes that go on for pre-processing, processing, and post-processing, all those will be addressed. And then, like I said, based on the material that you're using, if you're using compound materials, if you're using earth-based materials, adobe materials, or concrete or cement-based materials, each standard will have you will have a set of standards that will be listed addressing each type of material and solution. So yeah, we're trying to address that as much as possible. But again, trying to reference existing documentation, not necessarily recreating everything from scratch or reinventing the wheel that way.
Mm-hmm. And from an architectural perspective, structural engineering is not your primary concern. So the rebar placement and that stuff is left up to the architects and engineers.
Correct. We're trying to make the standard as less complicated as possible. So all the architectural elements have to be addressed by the architect offsite. So like it's out of our scope. If anything changes in the 3D model, because like if you're trying to go print and somebody changes the 3D model to something else, then it still has to go through the architectural certification. So we try to we say, okay, give me the final drawing, have it certified by the architect, and then we can print without the guy printing making any changes to the design itself. So we're trying to eliminate that step and just assume that once we get the 3D model, it's actually certified and accepted and approved by a licensed architect.
So does that get us closer to architects recognizing 3D printed concrete as structural elements?
Yeah, I mean, like if you look at the print that Saint-Gobain did or Weber BMX in Netherlands, I mean, they had load-bearing walls according to the news briefs. So yes, why not? I mean, if you're doing, instead of having rebar placements or having formwork printed and then filling it with rebar and conventional concrete, maybe the print that you do with the honeycomb type style or anything that the pattern that you're printing would actually hold the wall. And again, the tests will actually prove that. But we're not far away from, if we were able, the test that we were able to do initially in 2018 proved that the material was actually 4 times stronger than conventional and was able to hold the load of a roof and subsequent floors, then I don't see it being an issue at all. Plus, with BIM design and 3D modeling and everything like that, which is the basis of every design these days, it's a natural progression moving forward.
So the testing standards, you test less than the full building. So you don't have to build an entire building and then destroy it. You can test sections or?
Yeah, well, we can test sections at now. Later on, when things become cheaper and more or sort of like more economically set, then yes, you can actually print the house and then test it and do loads on it. Certain prints that have been done already, for example, Skopelt in the Czech Republic has been able to actually test their structure to actually hold 50 tons worth of weight. So I mean that's for a 1-story building. So that says a lot right there.
Holding 50 tons in compression.
Yep.
What else should we cover?
That's pretty much it from my side. But I mean, like, if there's anything else that you want to talk about, I'll be more than happy. It's just growing. I mean, like the nice thing about it is that, I mean, in the US itself, like I said, in North America, things are moving forward. Just in the last few months, you have 3D printing companies, 2 of them in Utah area. You have many of them that are actually coming up in the East Coast, Texas, Midwest, and so on. So, I mean, like it is actually picking up. And just the fact that Cobalt is actually now in printed farms and with Perry, US, and you have these big international companies and big companies that are actually pushing this through. So the acceptance is going to be quick and adoption is going to be quick as well.
That sounds good.
Yep.
All right. Well, I think we should certainly do another podcast like this somewhere down the line, whether it's 6 months from now, a year from now, when the little more progress has happened with those regulations, have more to talk about. I think it'll be really great to keep everybody, my audience, updated with what you're working on and where the progress you're making is going.
Yeah, I look forward to it and be more happy to do it. So as soon as there is an update or some major change, I'll keep you posted.
Awesome. Well, thanks for joining me today.
Thank you for having me, and nice talking to you, Jared. Nice to meet you finally.
Nice talking to you as well. Have a good day.
You too. Take care.